All right, so I'm talking with Alex, and we're going to talk about sunsets today, just a little bit. What we're doing is going through the scientific method and seeing if we can show that sunsets prove the globe. Is there anything you want to say about this, or?
So I'm not sure if anything can prove anything 100%, but for sure with the sunset you can disprove flat Earth. That is for sure.
Well, that would be based on understanding, but what we're trying to do is prove the assumption of the globe, not anything to do with flat Earth.
You cannot prove anything 100%. That's not scientific.
Well, that would be that's just something that said, but can you prove that you're drinking water when you have a glass of water?
Yeah, pretty much, but
okay, so that 100% thing is that's not really an accurate or a logical statement. It's illogical to say that you can't prove something. But I understand if you could say I can't prove it, it just the evidence points to something. I understand you could say that, but you can't really say you can't 100% prove something scientifically.
Yeah.
Okay, so the observation is sunsets, right?
Yes.
Okay, so in your observation, and this video that I have on the screen is not your observation, right? It's just a video basis for our conversation, right?
Correct. I did not make that video, but that video shows what I have seen a couple of times myself, and what
sure, we've all seen sunsets, but what we got to do is so when we're going through this, do you just want to like stick to the observation today of what we can see, or do you want to get into like the other steps of the scientific method?
So first we can take a look at what we can see in that video, or what everyone can just observe every day on the world. And then we can use the scientific method to show, okay, we have two different models. And then we can see, okay, the predictions of each model and what model matches the prediction with what we see.
Well, to subscribe to a model, right, is not going to be I mean, a model is something that you use to demonstrate something, but that don't mean the model is correct according to reality.
No, I mean, a model is a description of reality, right? A model is
yeah. So right now, what do we observe just from where it's still shot?
Sorry?
But you can't be in here. You can't be in here. What can we just see? What can we state we can observe just from this still that's on the screen?
Yeah, the sun is about to set on an ocean.
Right. Okay, and the sun is small in size, visual size.
Yes.
Like it's shrinking as it's going away.
No.
Well, it looks like it's tiny, like it's about to disappear.
Yeah, but you can go out, take a solar filter, and you can see that the sun's diameter is always 0.5 degrees, no matter when you observe the sun. The sun does not shrink. That's an observational fact.
Well, in the right conditions, the sun does shrink.
No, like in a desert. Sun does not shrink.
In a desert, like I've seen, like I was myself in the desert, the sun does shrink due to the dryness in the air.
No, it does not. No, what you're saying is not correct. Either you have been observed correctly, or you are lying.
One of I'm not lying.
But the sun is not shrinking. When you observe the sun, it's always 0.5 degrees in diameter, no matter where or when you observe. That is a fact.
Well, look how tiny it is, right?
I bet my life on that fact. But you can go out and observe, okay?
I wouldn't do that. I mean, what if you're wrong? Then what happens?
I have observed the sun hundreds of times. I never
Well,
seen
sure, everybody has.
a change in its size.
Okay, we'll leave that aside for now because I don't have the video of a sun shrinking in the desert pulled up. But okay, so now does the water here, because we can see the land, does the water look like it's curving from side to side?
No.
Okay, so the water is not curving from side to side neither.
You cannot see. Maybe it's curving a bit or very small. You cannot see. You can never say it's 100% flat or something like that because you cannot measure 100% anything.
Yes, I can. Yeah. I can absolutely 100% measure 12 feet.
You
cannot. I can absolutely measure.
You cannot.
I absolutely measure 12 feet in construction all the time.
Perfect distance. You cannot. You cannot measure perfect.
So let me ask you this: what's the distance from the observer to the apparent horizon out there?
I guess from that close, maybe 3 miles or something.
Do you know that?
Hello?
No. Everything you say about it's going to be speculation because you don't really know.
Yeah, that's correct. In that state, without anything else, knowledge, I cannot say that. That's correct. But you cannot really see distance.
So
you're breaking up.
Since this is not my observation.
All right. Now I'm alone, alone. Bim, 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 bim.
Alex, I'm back. Are you there?
Yeah, I'm still here.
Oh, sorry, my internet glitched. Okay, so what I was saying was because this is not your observation or my observation, we can't really know the distance to that horizon, the apparent horizon. It would just be speculation.
Yeah.
Maybe in the video we can see more. But what I observe in this still shot is that the sun is shrinking. I can't determine it from any other thing or it's small anyway, visually small. I can't determine if it shrunk or if it got bigger or throughout the day because
I mean this is an image. It has one size. On one image you cannot see if it's shrinking or getting bigger because it's just
no, I know. One image. That's what I was saying. That's what I was saying. We can't tell if it's shrinking or not. But we can put that aside. I mean, that's not going to be really relevant. But so what we have is what we can observe from this still shot, I'll play the video here, but the sun off in the distance and the horizon of the lake, we don't know how far the horizon is, and we're not going to be able to determine that. Okay, I'm going to play the video here.
Yeah.
Okay, now they're starting to zoom in, which as they zoom in, the angular size of the sun gets larger as they zoom in.
Yeah, because you zoom in. Yeah.
Yeah, that would be like if it's getting closer or further away, but we don't need to go back and forth about that. But the angular size is going to get bigger as they zoom in.
No, the angular size is the same. It's just magnifying things. The field of view of the image gets smaller, so the angular distance size of the sun stays the same.
Okay, so now what do we say we can observe from here? What do you say you can observe?
The sun is a circle, and the lower part is missing. Oh, look at that! It's missing. Where did it go?
But that's an observation. Okay, so what is that? That's just an observation. The lower part is below the apparent horizon.
That immediately shows that Earth cannot be flat.
What you're doing is you're using the assumption to prove the assumption. You're assuming the Earth is a ball, therefore the sun is going behind the physical curvature of the Earth. But you're not proving the assumption of the Earth being a ball or a globe. You're taking that as your conclusion. You're taking it as your conclusion.
I can disprove flat Earth because flat Earth says the sun is above the ground, and here we see that's not possible.
But that doesn't disprove flat Earth.
Yes, it does.
No, it doesn't, because you're not taking into account what it would be doing on a flat Earth. You're just dismissing it, and that's why this is not about flat Earth. It's about you actually providing evidence for it being proven the assumption of the globe, and not just saying the conclusion is a globe, therefore the sun is setting behind the physical curvature. That's not the scientific method. You're taking out the whole method and coming to the conclusion based on your biases.
What biases? I mean, I have this model of flat Earth. It says the sun is above the ground all the time, and here you can see this prediction of flat Earth does not match observational reality.
Oh, sure it does. but that's the thing. And when I went through the conditions, that's why I wanted to make it clear that it's not about proving flat Earth or disproving flat Earth. It's about proving the assumption of the globe. But you're taking the conclusion of the globe and making it the assumption.
That doesn't make sense.
Well, it does, because you're not using the scientific method. So you're just taking your biases, saying the Earth is a globe.
No, I want to use
the scientific method.
The scientific method is you take these two models, you make predictions, and you compare that with reality.
No,
that is the scientific method.
In the steps of the scientific model, there's no comparing model step.
Yeah, you make predictions of a model, and then you compare that with reality.
Okay, let's continue the video here.
Mm-hmm.
Okay, so now they're zoomed in almost to their max, and they could just be using a phone to zoom in, right?
Doesn't matter.
Well, sure it does, because if they had a more powerful zoom, could they zoom in more?
Yeah, but why more?
Why not more?
It just gets bigger. That is zoom. It makes things bigger.
So in the scientific method, you would have I'll pull this up. So this is our scientific method here. Okay. So you have an observation, and that's what we're looking at. The sun is going beyond the horizon, or the bottom of the sun is being done beyond the horizon. Now we can we can formulate some questions and formulate a hypothesis. And so I would ask some questions that would need to be answered in order to formulate a hypothesis.
So the hypothesis is the Earth is round, no?
Well, I'd ask questions before I just formulate a hypothesis. But your hypothesis would be the bottom half, or the bottom of the sun is being obscured by the physical curvature of the Earth. That would be your hypothesis, right?
Yeah. Okay. Sure.
Okay. Without asking any questions like what kind of camera are they using? What elevation are they? And I understand you don't think none of that plays a role, but it does, because if you had a different size camera and a slightly higher elevation, maybe you could see more. And because it's going beyond curvature.
Doesn't matter, because either way the sun sets anywhere.
Only thing I can conclude from the video is that their camera is not capable of zooming in more.
Why do you want to zoom in more? I mean, it's big enough. I can see that the lower part is hidden behind the water, it seems. Why would I zoom in more? To have the whole screen like yellow?
No.
Why?
Okay, let me because if you can zoom in more and see the whole sun, then it's not behind the horizon. If you could do that. Of course
not. I mean, this is bullshit. You don't believe this zoom in stuff. You can zoom in the sun. Then zoom the sun in the night. Do that, and I give you $30,000.
Okay, I'm not interested in your.
Give me a video where you zoom in the sun at night, and I give you $30,000. I give you $30,000 when you have a video where you zoom into the sun at night.
That makes sense. I'm not interested. I'm not interested in a payoff. I don't.
Okay, of course not, because there is no such video, because you cannot zoom in.
Well, that doesn't make any sense, because
you can't.
You're using your biases to say that the sun would.
That is no bias. That's simple optics. Bye.
Okay, he left. So what happens normally is going to be they're going to get super frustrated. He started cussing, and it's just they're not going to continue in a conversation. So I'm going to continue this conversation on my own, I guess, because he chose to leave. And so the argument is that the sun proves that it's going. The setting sun proves that it's going beyond the curvature of the Earth. Okay, so I guess I'll just play this a little bit longer to see what happens. Just zooming in, just going past here. We don't need much here. Okay. And then actually it goes into the atmospheric deck of opacity. And you can see that here at the end. It doesn't go down any further. See, it just vanishes away. All right. So that's we don't need any more of that. Okay. Remove that. All right. So, and I'm sorry that Alex got frustrated. And it's a typical thing that happens, but you'll never go through the scientific method. They just won't do it because because it's always going to be the same thing, right? You can't go through the scientific method and actually prove the assumption of the globe. You need the globe to be assumed. You need it to be a globe in order for the condition, for the observation that you're claiming to work. And so you go through the scientific method and actually see it for yourself. So just looking at the scientific method, I would ask questions about the camera and everything else, and the height, because it all plays into a role of your answer, right? So the observation is the sun sets behind the curvature of the earth. Now I started asking questions like, how far away is the horizon, the apparent horizon? What kind of camera was used? What's the temperature? All those things play a role. And the reason why they play a role is because you have to form a proper hypothesis. And in doing so, then you can start experiments. I don't think we'd ever get as far as, past the observation, because the problem is that they need their narrative in order to get the observation. Okay. And then we would never even get to analysis or conclusion. But in the questions, in the area of questions, you ask questions to where you can make form a correct hypothesis. And I don't know what to say. He got upset, and I'm not sure why. And then, cussing and everything else, but so why does then we try to answer the question, why does the sun appear to set behind the horizon, right? And that's how we would go about it. We could ask questions about that. How would it work on a flat earth, and different things like that. But I don't know. So what I really wanted to do was try to get through the observation, but you can see at the end there that it was just a fadeaway of the sun, and it appeared to go beyond the horizon, but it's all perspective. And so you're going to have an angle of view, and that angle of view is going to collapse, and the ground always comes up to your eye level. So if the camera is low towards the ground, the ground is only going to come up to your eye level. Then the sky is going to come down to your eye level, and where those two meet, that's called the vanishing point. But the sun, being that it's in the background, it doesn't change in angular size. It doesn't have to change in angular size because it's in the background, past where the vanishing point would be of the camera. And it'd be hard to explain that, but I'm going to get into that sometime. I'm going to make a video on how that works, but it would be like, you can see right with this shelf here behind me, you can see how it's going into perspective here. Okay. Now if that perspective would continue, right, it would be a point at a vanishing point, but that big, thing in the background there would still be the same angular size, and it would be the same angular size as you bring it above you at the same distance away from you and everything like that. But your perspective is going to come bottom up first, so the shelf over here, you can see where it looks like it's going smaller, but it's just perspective. And that shelf is only 3 feet, 2 feet, a little bit over 2 feet wide. And even in 2 feet behind me, you can see the perspective of the shelf. and it's coming into a point. But anyway, perspective answers most of the questions. I tried. It doesn't really work out. The frustration level gets too high and they can't even answer. All right, I'll end this video today.